I am good. Just having a lazy Sunday, taking a break from the code.
That's good. You have
Nice.
so much criticism from us, but that's good.
Uh,
It's nothing for
Yeah.
bad.
Dico said we're gonna be better than Solana, so that's good news.
Well, it's good to set the kind of like aiming for the stars type of goals. I think it's good. It's not really that amazing to fork the chains and just make them change a couple of variables and then off you go and you call it a new chain. I think it's much better to actually design technologies that can shift the paradigms of kind of like today's status quo and push the state of the art forward. I think it's a worthy goal, even if you fail. I think it's good to try.
Yeah, totally agree with that.
So Jack,
Okay.
I have a question. How do you? So we see Xenblocks, we see like the engagement. People are excited. People are mining. The people who have never mined before are actually looking to learn about it. Where do you see it going in 6 months, in a year? What's your plan for it? Have you thought about it that far out, or is it just something that you're toying around with at this point?
So I was actually surprised how well the our community responded to the whole project, and the whole thing started as just experimental weekend thing that I didn't even think it's going to go beyond a weekend. And now I think 45 days later, here we are. Um, quite, you know, I would say really good engagement from the community, and we definitely learned a lot. But I think the whole thing, how it started, is that obviously you guys know that I've been in the design phase of X1, which I wanted to fork Phantom because Phantom is one of the best EVMs out there. They use the directed acyclic graph, which is extremely fast, and I know them kind of personally, so it's a good team. So I figured there would be a good base to build on. But then uh, more and more often, as I thought about it, I realized that the security layer of a fork chain really could be better versus, like, for example, tokens that you just mint out of thin air and then you give a bunch of hopium to people and have the price pump and then somehow have uh, the minted token somehow secure the chain. So it's kind of like a chicken and the egg. And if you guys remember Ethereum, they started as a proof of work chain. Um, Obviously, they did mint Ethereum and they did sell it, but they did start as proof of work, and ultimately they got rid of most of it. They sold most of it, and now the Ethereum Foundation controls less than 1%. So Ethereum is currently one of the one of, I would say most decentralized in the EVM space. So but it took them a long time. Obviously, it took them years to get there. And I thought, well, since then there were so many chains that simply forked Ethereum, made it better, but the economics just did not make much sense to me. And again, I thought about Phantom being one of the best chains out there, and yet the economic power of the chain is really really weak. And I kind of realized that the technology in terms of the chain speed is not definitely not one of the driving factors. It's there's many chains that are fast, and a lot of them don't have any TVL or anything like that. And that kind of brought me to think that it is really the community engagement that makes everything worthwhile, not necessarily the technology itself. And just to give you this one example, let's say that there's a team that produced an amazing chain and then nobody knew about it, and now they like released it and say, hey, we're like the best. Now, will people necessarily end up coming to their chain and use their chain? I'm not actually sure. I think definitely it would attract pump and dump mentality from the community, but not necessarily long-term engagement. And we see it on many different chains that are coming up under this premise. So Xenblocks when it was in the experimental stage, definitely attracted a lot of engagement. And again, the community just sub-educated, which is amazing. So the miner that's running the GPUs right now is not even my code. So it was created by someone else, which just kind of like indicates that people are really excited about this sort of thing. And I think part of it is obviously proof of work is just this very, very solid process to give value to cryptocurrency. And you don't have to pre-mine it, pre-mint it. You can just let people mine it themselves and give the value of the effort that they produce themselves without any sort of central figure. So that's really good. And yeah, so I think Xenblocks being as a security layer for X1 is a really good idea. And it also, given that we're in a bear market, we're not under the pressure to pump anything. And again, like if we were to go with just the proof of stake, the stake has to be worth something for the chain security to actually be functional. And without that, it's like there's no way that you would end up staking your coins thinking that you actually enticed or encouraged one way or the other to secure the changes, because those coins are not worth anything to begin with, which is very, very different from proof of work. So that's why I'm so excited about the project right now.
That's awesome. Well, I'm mining. Sorry, I hope you guys don't mind. I have one more question. So I guess you mentioned it's a security layer. So Xenium is basically, you can use it to get nodes, but can you talk, like, is X1 the gas token? Like, so just how do those two things interact? Like, what does it look like, Xenblocks with X1?
Well, so we haven't really decided regarding the economic setup of the two projects, but we think that Xenblocks can become the security layer for X1. So X1 is the EVM chain that can settle on Xenblocks. And obviously, it's kind of like becomes this smart contract layer on top of the proof of work chain that has very well designed Xenium distribution. And I think ultimately, if this year or into the bull market, people end up mining a lot of Xenium, that it actually will have very good value to secure X1. So that's what I'm thinking.
Big Club, before we go to you, I just want to reaffirm the proof of work thing. Because, so Jack, if you don't know, I'm in California. I'm in San Jose, Gilroy area. And for me, peak time, it's like 50 cents a kilowatt, which is insane. I was like, I'm gonna buy a bunch of 4090s, and I was really about to buy some. I was right before the purchasing, and then I mapped it out. I was like, oh wow, this is gonna be really electricity costly to do this, and it's more cost effective for me to use a virtual miner to mine. And that's when I was like, it clicked. I was like, oh, this is gonna have some value. Like Xbox is definitely gonna have value. It's just expensive. So yeah, proof of work is definitely proving true in that concept.
Yeah, I got bro the GPUs for 7 cents. So in the UK is a wholesale price of electricity, but it's good if you find.
Yeah, it's insane.
Nick,
Yeah,
I want to ask you, do you continue with the Phantom fork as a for X1? And I came now because you said about the security layer.
Yeah. So
The security layer. Do you think that let's say X1 when this comes out, maybe Xenblocks can be used for coming, or somebody creating, or you can create, or anybody else, another blockchain that can use the security from Xenblocks, because you can multiply the smart contract blockchains, or something else can be attached to Xenblocks. Have you thought about that?
yeah. So I mean, definitely. Well, obviously EVMs are the most popular virtual machines today, but anyone can build a virtual machine on top of Xenblocks. I would say if Xenblocks acts as a security layer and basically settles your transactions really, really, really fast. So I'm aiming for the release of transactions first, and I want those transactions to be as fast as 200 milliseconds for the confirmation time, so faster than Solana. I think Solana is 400 milliseconds today, so I think a good goal is to be twice as fast, at least, for Solana versus Solana to this. And one of the ways that we can achieve that is so Solana chose Rust language for their development, and it's a cool language, and I definitely play with it, and I think you can do a lot of things. It's a lot closer to C than, for example, Go language. That's most of the EVMs, including Ethereum, use today. The problem with building a project on Rust is that you have very limited access to open source technologies. Like, for example, the peer-to-peer layer, Solana had to invent all by themselves. So they had to go to the packet layer and really to accelerate their chain, and they had to spend millions of dollars to develop it. And a lot of it was done by trial and error, where if you use Go language, you don't have the sort of novelty where there's actually a lot of open source projects that support Go language or Golang, and one of them is like P2 or lib P2P, which is an open source project, works really well. We've been testing it over the weekend, and we don't have to invent anything. We don't have to go to the packet layer or to the network card layer to accelerate things like they're doing with FireDancer. And FireDancer is the implementation of the Solana client in straight C language, which they think is going to be even faster. But the thing is that the speed itself is awesome and it looks great for for marketing. But if you end up spending tens of millions of dollars developing it, and even worse, a couple of years to get it right, rather than using an open source project, I think just going open source is much better. And I'm not saying that Solana isn't open source. I'm just saying that Rust language does not have that many open source packages that support it.
Yeah, Rust is used also in now in the using in Bitcoin, and I think Nix project is using. They have kind of a Rust, very good support even for Bitcoin and stuff. So yeah.
Execute and then love on.
What's going on? I was talking to Zensu last night about this, and I was kind of just put like a little bug in his ear. Elon was on the Joe Rogan podcast the past 2 times talking about open source and open AI and all these upcoming AI technologies. And I was telling him that you guys should somehow get in touch with him, because if he wants to keep building AI, I think like the best way of doing it is to put it on the blockchain. That way you always your people always have like some type of rollback function where if it gets too out of hand, you could always either do a rollback or fork and then go with the next type of stuff. Because he was saying everybody that like Google and the other top 5 that is building any type of AI feature is it always rears to the left because of where it's being built and whatever else, and it just comes down to founders. And I don't know, I just think you and Zensu and those guys, like you're pretty center. I don't think you're right or left, and it's open source, so it's always good to go with that. I don't know if
open
you
source.
watched the podcast or anything, but he's definitely looking for people to get behind and to find the right people. From what from what he's talking about on the podcast.
Yeah, I saw just bits and pieces of that podcast. I need to listen to it in this entirety. But I would say, unfortunately for the AI stuff that's currently being developed, is that politics always skews the data control. Like, in other words, it used to be without internet, where the politics and viewpoints were just transmitted through the newspapers, and now newspapers are kind of like shitting their pants because the information is unstoppable, and it goes through through all the mediums. But even like before Elon bought Twitter was heavily left leaning, and they was censoring other voices out there, which is definitely not good. So I'm very happy that that he bought Twitter, and now it's, I would say, more even keeled, so to speak. And I think open source plus decentralization should really be on the first and foremost front, rather than the control of information, because you know how they say those that control information control the world. And I think we definitely want to stand for freedom of expression, freedom of speech, obviously, sovereign control of your wealth, and also control of what is that you want to learn. Like if you want to learn facts about the world and you're using AI system, you really want to get the answers that are not politically influenced. Just get to the facts, like get to the science of it, like not go across the chasm of what's politically correct and what's not. I mean, that's like really is a big issue with most of the AI platforms today. Like I would say, like I use ChatGPT for code, and it's really amazing for code. But anytime I ask it, I would say some of those sticky questions, it's always end up moralizing. Like it's saying, oh, it's this and this and this, but you need to make sure that you interpret my answer correctly and blah blah blah. so it's definite, you can definitely see the political correctness as part of the training of the AI. So, and I'm not saying that things should be like crazy, right? But at least when people ask for the facts are delivered as the facts without any sort of kind of like leaning to the left or to the right. So just should be information. That's all.
Yeah, we
Yeah.
seem to have lost.
Hey, I got a question for Cypherius Prime. Do you still support the DBZen protocol? And why was it taken down on the Zen.network?
Uh, Zen.network was so basically it was like this. The ZenCrypto.io is a community website that covers all of the protocols, like all of them. And obviously DBZen was one of the first ones that came up, so we had it on the website just because it's one of the few, like maybe one of the two, basically. So it was like Phoenix and DBZen. And then as new projects came online, it didn't make sense for us to only keep Phoenix and DBZen linked and ignore all other projects. But we couldn't put them on the website altogether anyway, because it would be like way too much. So we made a decision to keep it Zen only and rather link to zencrypto.io, because zencrypto.io covers everything. So now we're just sending people to zencrypto.io, which is a community website. It has kind of like this really good view of the ecosystem. So we think it's just better for the end user experience.
All right, cool, Cypherius Prime. Appreciate the honest answer. So there you guys have it. He still supports the DBZen protocol, so don't worry. He's still good. All right, you guys are good. You guys have a blessed Sunday. All right.
Well, I think DBZen is awesome. It's like amazingly done thing, and it sticks to the principles that we outlined originally in the Zen white paper. So definitely kudos to the team, and it's an amazing thing. I hold a lot of DBZen myself. I never sold. I bought a bunch over the months, and I just want to keep it for the next bull market. So that's kind of like where I stand, and I like to invest into the Zen Universe projects here and there. And DB Zen was like one of those things that I was leaning into just because I like the team and I like what they were doing. But I would also say that yes, I did all those things, but DB Zen does not need my support. I like it, but the truth in decentralization is that no person should be able to influence a protocol because it's there on chain and it's immutable, and it's up to the community to make it great or not great. So that's kind of like where I stand with all of the projects. Like it would be very bad for our community and for Zen Universe for certain people that are well known to choose one project versus the other and say, okay, I like this one but not that one, because that's just not what we stand for. We stand for full access, decentralization, immutability, open source, and in people's freedom of choice. And we don't want to skew that choice between the protocols.
If you think one person can't dictate one protocol, you've never met Cleo.
I'm with Cleo, and I mean, we need people like Cleo in the community, because it gives us something to be passionate about, and he definitely brings a lot of passion in many people. So I think I'm thankful to him for that.
I have another question, if you guys don't mind. Just to build on what Execute asked you. So I follow a guy who he puts like Chat GPT 3.5 on like calculators, and he seems to think that we'll have our own AI, and it'll be localized, which I agree with. And so if you have a localized AI, then it will be as diverse as individuals are diverse, right? So, and that will kind of be a hedge against centralization. And I feel like crypto is the answer to that, where you would have an AI localized, and you would need a private key, because you would want to give it so much access to your mind because of the benefits that it brings, but privacy would be paramount in that situation. So my question to you is, with the protocol that you're building, is the technology there where you could host that much AI individualized, and where people would have their own private keys, and maybe they would have zero knowledge proofs so that they can access the internet, but they don't want to divulge all the access that they gave the AI? So have you ever thought about that, and is it possible in blockchain?
Yeah, so it's definitely possible. The problem with the current AI implementation is that when you have a single GPU unit, it has to load a trained model into its memory, and it can only handle one question at a time. So it cannot handle multiple people coming and asking questions at the same time. It just will not be able to work like that, uh, which forces the AI companies today to bring up farms of GPUs that load the models and have that traffic of user questions load balanced across all of those servers. So it's definitely very, very, very expensive. And until the models are able to be linked across this executive units, the GPUs, in a sharded form, it will be very difficult to have a cost-effective solution uh, as a free solution to this. It's just like, for example, if we have validators that are running GPUs, they can definitely lend their GPU power for model training in model accessibility. That is definitely possible. And I have private AI models running on my servers just for experimentation, and I have built my own models myself too. But the limitation, unfortunately, is the cost. So right now it's very difficult to do it that way. However, if, for example, running GPUs were not as expensive, and you could have a token linked to the usability of the AI models, then there could be an economic incentive for the validators to run GPUs and actually host models and have them be user accessible in a safe manner, where all of the questions and all the answers are encrypted, and there's like no way that anybody can track anything what you're talking about.
What if you made it some type of plug and play? Like I've been doing that kind of recently. I downloaded the 4chan OpenAI, and it's absolutely hilarious. It's pretty weird, and just the shit it comes up with. Like you can be a comedian really quick on that thing. I think that's also another way of like making it more decentralized in the future. I think it could go just plug and play, where like if you want certain types of ways of thinking, you can plug and play from this certain genre of the internet. You know what I mean? Like they could also
Yeah,
build it up that way,
yeah,
and you
for
just have
sure. So
the whole thing.
I played with the 4chan model myself as well, and what I was doing, I would just rent the GPUs from RunPod, and I would rent it for a couple of hours, use it, and then I would shut it down, and the cost would be like $5 or something like that. So it's definitely possible in this sort of like load the instance, interact with it, shut it down, and let other users use it. So that is definitely a possibility, and this is something that we're thinking about implementing in the future. But first, we do need to design and come up with the economic layer that is secure enough, where there is value to the token and in the crypto coins that we're producing, so that we can actually have the value exchange where people can bring in their hardware and actually get paid with something that has value.
I got another question from Zen Celebrity, listening to our space right now. Is hold on a second. Is VMPX still getting X1 allocation?
So we're obviously said that it would, but the thing about crypto and crypto world, it's like a living organism. It's ever evolving, and so we have to obviously evolve and always make changes to the ideas, whether it's enhancing them or manipulating them to make it better. But the end goal is always the same: to bring economic energy into the system and produce good outcome for everyone out there that is fair. And so we're following those principles, and it is what's guiding our decision based on what we do with the tokens that we have released. VMPX originally, when we launched it, was just like really just a meme coin. We didn't even know what we were doing. We launched it. It created quite a stir on the Bitcoin network. It actually attracted a lot of Bitcoin builders to the Zen universe. And as we interacted with those people out there, we realized that VMPX really should be part of our ecosystem, just because a lot of people want to build with it. And one of the teams that's building with VMPX currently is a Libre team, which is a team behind a Bitcoin to Ethereum bridge. So they're working on that, and they just want to make Bitcoin work better and be wrapped in a proper way, not like wrap Bitcoin today. Like WBTC is really just a treasury of Bitcoin that hold with admin keys. So there's ways to make it better, and that is where we're trying to plug in VMPX into. And of course, as things develop and things become more apparent, there probably will be changes. So I cannot say yes or no right now in the most definite kind of way. I would say that we do want to use it, and for sure it's going to be part of our Zen ecosystem. But exact details are not very clear.
It's an agile environment, guys. Welcome to the tech industry. What's up, Honeydews?
Hey, guys. Hey, Jack.
Hey,
So I would like to bring a question. It's a little bit subtle here, but I think it's kind of something that's just in the background of people's mind in regards to Xenblocks, and it has to do with this kind of contradiction between fairness, right, and efficiency or free market. So it's like in first principles, the way I see it, you could think of it as like fairness, being fair to everybody, or you could think of it in the way of allowing free markets to decide, like just freedom, right? No trying to control anything. So when people ask, like, what is it worth to mine Xenblocks? Is it worth it? Like you said in the beginning, Argon 2 was being used to kind of balance the ASIC mining, or the CPU mining with the GPU mining, and try to balance it out so there's no clear advantage. But then obviously there are advantages, like energy is used more efficiently by the VRAM on GPUs, and there are certain things which are not of your control or anyone else's control. It's just a technological thing, and you decided to basically just allow things, whatever's most efficient, to be most efficient. Now, some people will say, well, yeah, but then those who have those GPUs, or maybe it's going to be ASIC miners or whatever it is, have an advantage, right? So my question, what I'm trying to allude to here is, and it's the way I see it, is that is it not valuable to allow the free market? Can you speak on the why it would be valuable to allow free market to do whatever it can and is best and most efficient, as opposed to trying to control fairness in an artificial way? And why that would make whoever mines Xen blocks, even if they're mining less, more valuable, because the market is free to come secure the blockchain and use whatever means they have to do so, as opposed to be gate kept or controlled or told rules and regulations of what they're allowed to do and not allowed to do.
So that is a very deep and very interesting question, and there's many ways to answer it. But the first thing that I will say is, we're not really in control of what can be done with the Argon 2. The reason why I chose Argon 2, and again, it was in the experimental stages, is because it is well-known memory hard algorithm. Memory hard algorithms are linked to memory and RAM usage, and that is the only thing in the silicon world, in the semiconductor world, that you can not really optimize on price. So in other words, if your system needs 1 gigabyte of memory, of that RAM, you cannot really build your own RAM. You can find a better distributor that gives you like 10% discount, but it's not going to be like 80% discount, because the RAM market has been pretty much commoditized and been settled.
Am I rugging or?
I think my internet went offline for just a second.
Oh, okay. Freaking out.
Yeah, so what I was saying is, Argon 2 is memory hard. You cannot optimize memory. Every other algorithm out there that is not memory hard, you can just build specialized hardware. So, in the second part of your question, is it good to give market the choice? Obviously, it is good to give market the choice. But I tell you this, though, it is not even our choice to control that. We cannot control which algorithms people want to use or not to use. Like the reason why people use Argon 2, well, it's because it started as Argon 2, but somebody can fork a chain right now and plug in SHA-256 or anything else that they want, and it's going to be another chain because it is open source. It's just people are willing to participate in this project based on the social consensus today. But let's not have any sort of doubt. There is no single entity that controls the choice of an algorithm, because I don't have any sort of voting power to tell people what to do. People just decided to do what people are doing. I cannot say that, okay, now we're changing algorithm and you guys better comply. Like, that would be anti-crypto. So that's what I would say.
So okay, just to be clear here, because the reason I'm asking this question is for those of us who would wonder if it's worth it to participate in a network where, you know, some might have an advantage over, let's say, CPU. So let's say I only have a CPU and I want to use that, but I'm going to get less Xen blocks because all of a sudden there's people using ASICs. On the other hand, if people are using ASICs and they're willing to spend the energy and hardware to do it, because they can, because it's not controlled like you just said, and you can't control it. I see that as a positive, even though I'm getting less Zen blocks, than to say to control it in some kind of artificial way where you say, no, you can only mine with CPU and nothing else is allowed. And then you have a bunch of CPU miners, but you do not have the hash power or the amount of energy being spent to secure the blockchain. Would that be true to say that it is better to have the more powerful equipment and hash power come to the blockchain as opposed to having many more small entities in a kind of fair kind of way? I don't know if you understand what I'm saying here, but it's like, I think it's a question people wonder, this fairness thing, is it a good thing or a bad thing? The fact that they can't compete with, let's say, Asia, for example.
Jack, we can't hear you. Unless I'm rugging.
I hear you.
Me too.
Jack, I think he's
You know,
back.
strange
You
thing is
back?
my internet too, bro.
Yeah, something happened to my Wi-Fi. Like it went in and out for some reason.
Yeah, mine too. I'm still out.
Okay. Yeah, we have wind in Hawaii, so maybe there's like a network that got knocked out.
Did you catch the gist of what I asked you, Jack, about the concern that maybe people that don't have GPUs or ASICs, about how it's actually could be a good thing to get less Zen blocks, but be able to have that power to come to the network and secure the network. Like if there's big players, like we saw the other day, right? 1.4 million hash per second came in. Now, we don't know how long that's going to last. That may be someone who do it for a few days, a week. But regardless, in the big picture of things, would it be valid to say that when those big players come and start securing the blockchain, however many Zen blocks that I mined with my GPU or my CPU, that's a good thing. It increases the value of the network and increases the value of whatever I was mining. Even though I didn't mine as many because he hopped on, it's still a positive thing.
Yeah, I would say you're right about that, and we can draw the parallels with Bitcoin. Bitcoin used to be free to mine. You just use your laptop and you just mine shitload of Bitcoin. And then as it got popular, it is now impossible to mine. The barrier to entry is very, very high. So it's like an NFT that got very expensive. So I think the fairness does exist, that you should be thankful that you cannot mine Bitcoin today by yourself if you mined it 10 years ago. So it's always a good outcome for something to get more scarce and more difficult to get. So I totally agree with that.
Okay, cool, awesome. I just wanted to clarify that because it is confusing, right? Like numbers go up, seems good, but sometimes, if you end up with everything and nobody else is mining it, it's not a good thing. So, yeah, okay.
Well,
Great.
it's like gold, right? Like if you have access to gold in your backyard, you just need to use one shovel. Then it's just, it's not very interesting thing to own anyway, because everybody has it and everybody has an abundance of it. So it is impossible to secure economic energy with something that you can just take from the ground and put it in your pocket. It's just not going to be worth anything. It's like air or whatever else, the earth element out there that you can just get. So it would be dirt cheap, literally. So you want the difficulty to be there.
So I guess that what that means basically is the earlier the better. And if it ever, for whatever reason, it would subside, like people come in and mine a million hash seconds and then they don't the next week, then whoever's mining gets to get more, and it just vacillates, goes up and down. Like, I guess I don't know what the difficulty of Bitcoin was through the years. Like, I don't recall really seeing that chart of the difficulty, but I'm guessing it would be sometimes a little bit harder and sometimes a little bit easier, and you kind of can DCA in by mining just consistently. And as more hash power, yeah, we saw that when miners start selling their miners because Bitcoin crashes, and then the mining difficulty goes down, and then you can get some more. So that would be kind of the way to look at it. Like, it
Yeah,
doesn't
yeah,
right.
absolutely. Yeah, I remember the time when the Bitcoin hit $2,000 for the first time, and it's been sitting up there for like a month, and everyone bought miners, everyone bought ASICs, and as it crashed back to under $500, everyone sold their miners and sold their ASICs. I actually bought some at a discount, like 50% discount, because people thought like, okay, that's it. The pump is over. It will never be $2,000 again. And so I grabbed those miners for cheap. People, I guess, sold their Bitcoin, covered their costs, and then sold their miners. So I grabbed their secondhand miners and I just plugged them in to mine for a couple of years, and Bitcoin came back up. So yeah, I mean, like, those type of market conditions are totally reasonable and likely to occur with Xenblocks too.
Set it and forget it. You heard it here first. Man, my wife was in a meeting at PayPal about their stable coin, and they mentioned Ethereum. I was like, well, what do they say about Ethereum? Is it going to do well? Are they confident? She has no idea. She's like, I spaced out. I was like, God damn it. You're the worst spy ever. How am I going to know what's going to happen?
Yeah.
Yeah. But yeah, man, I think people that come to Xbox, it's because they believe in the Zen brand. That's why I started. I never thought I'd be investing in a GPU to mine or virtually mine or anything. And here I am doing it. I did every step. I did the CPU. I got a GPU to mine, and now I got a virtual miner. And I'm just like, I never thought I'd be here. And it's all because I just believe in the Zen brand. And I think
Well,
people that, yeah.
Well, I think we have an awesome community that's just helping each other to get things off the ground. And I would never imagine having a GPU miner being developed so quickly. It was literally developed 2 weeks into the project, and we have had the new community members that never heard of Zen before just come into Xenblocks and then get introduced to Zen. So that's very positive for the overall community growth, and I also feel like it's DeFi is kind of like in a dumpster nowadays just because of the bear market, but people can definitely learn the aspects of the blockchain technology without worrying about the chart, like, so to speak. So there's no chart with Xenblocks. And anybody who asks, like, when can I sell my Xenblocks, like, there's no answer, or nobody gets an answer that's very, very clear. And that's actually, I think, is a positive thing, because people can focus on just the technology aspect itself and get educated. And at the same time, feel like what it was to mine Bitcoin back in the day, because that's how I feel. I'm mining Xenblocks myself, and it's very similar to how I mine Bitcoin.
I have another question. I remember in your early days when you launched Zen, you talked a lot about, the network effect in your early days at Google. And I always saw the value in Zen based on that, the low barrier to entry, the first principles. And now, we're distributed across all these chains. We have a vibrant community. There's lots of interest. How do you see that all tying together, and how do you plan on launching something simultaneously with X1 that can capture that value exchange, like where we can bring our economic energy from the other chains into X1? Like, will it be a currency exchange, or how does that look in your mind, and will it be ready when X1 is launched?
Well, I think it has to be done very, very carefully. People do hold a lot of Zen and mint a lot of Zen. I have a lot of Zen mints coming up myself. So we need to be obviously very thoughtful about how we plug in uh, Zen from 12 different chains into X1 and how to make it worthwhile for the people. But I think, like Zen 2 often says, we need to demonstrate the technology and stability and kind of like economic soundness before we give any sort of promises in terms of like what can be done. But definitely, I think X1 is part of the Zen universe, and Zen holders should benefit from X1 launch. That is the goal, and we just need to very, very carefully plan it so that it's done properly and for the most benefit of our community.
If anyone else wants to come up and talk, just feel free to request, as long as you're not like a weird anon person. Cleonis 20 alts.
Did anyone have any questions about decentralization of Xenblocks? I heard some questions from before. People were like really interested in the roadmap and that sort of thing.
I think Bitcode was talking about like the
Jack,
decentralization of it.
I wanted to ask a question about the nodes. Do you have anything in mind or set what will be the node requirement and for running the node and stuff like that, or not yet?
So it's hard to say, but I would say that if we want it to be twice as fast as Solana, our nodes have to be pretty good. So we can look at the Solana node requirements and see what they require. And I don't think we need the nodes to be as fast, just because the way that I plan to design it is a little bit more efficient. But it definitely needs to have a good network connection, like not a DSL modem, something closer to fiber or Comcast, that sort of thing.
Yeah, the bandwidth need to be good.
But yeah, like I think there are questions about the decentralization. That's kind of what I was alluding to as well in regards to just on the mining aspect, but the Bitcode is raising the question of the nodes, the requirements, if it's going to be easy or difficult to be a node, in terms maybe of staking. Like in terms of bandwidth, I think that's not a huge barrier to have a fiber optics, but in terms of maybe proof of stake, like what is your idea? Is it to facilitate so that there are many nodes and the rotation? You spoke on the rotation of the nodes and the election of them, but in terms of the numbers and the facility for people to participate, is that part of the main objective?
Well, so the main objective is to give something for everyone that people can do. Like for example, if you're just a miner and you're mining, you're actually securing the network, and you don't have to have a fast internet connection. You can just mine with a couple of GPUs, or you can have some cloud GPUs. You don't have to run the full node to get the benefits of mining, and that will remain for, obviously, because it does bring benefits. First of all, you mine Xenium. Second of all, by being part of the network, you're actually helping to secure it. The other ways to run nodes is to run full nodes, meaning that you're actually handling transactions and doing all kinds of things on the executive layer, like executing smart contracts or providing stake pools, that sort of thing. So the requirements there would be different. You wouldn't necessarily need the GPU card at all, but you need pretty good number of cores, good memory, fast internet connection, because you're going to be handling the incoming transactions as they come to you. And the way it's going to work is there will be a security layer provided by the miners that will vote for the blocks, and then the nodes that stake and run full nodes will propose the blocks in parallel asynchronous way. And it's actually never been done like this before. So like even Solana, they have this concept of slots, and a slot in Solana is really a block, and they have a sequence of 4 slots that have to be produced by a leader, and leader is one of the nodes that is receiving all of these transactions and handling all of these transactions. The other nodes are waiting in the queue and are building their slots based on the work of the leader. The difference in our technology and how I envisioned it in the white paper is we will have the validator nodes that are staking that can actually listen to all of the transactions simultaneously. So, like for example, if we have 2,000 transactions a second coming in, then those 2,000 transactions will land on all of the validator nodes at the same time. And the way that we're going to achieve that is through broadcasting. So the RPC node will receive your transactions, and there could be several RPC nodes. Those transactions then channeled into this sort of a broadcasting layer that gives all of the transactions out to everyone else in the network. And 2,000 transactions per second is just a number. In terms of kilobytes, the transaction on Ethereum is 120 bytes, but we can round it up to, let's say, 200 bytes. And the reason why I say Ethereum is because we plan to use Ethereum compatible transaction schema. And so let's say 200 bytes, and you have 2,000 of them. So if you multiply 200 bytes by 1,000, well, you get 200 kilobytes. So if you multiply it by 2 to get to 2,000 TPS, you get 400 kilobytes. It's still not a lot of data. This data packet, 400 kilobytes, carries 2,000 transactions, can be given to all of the nodes out there pretty much simultaneously, which will then package those transactions into blocks in parallel at the same time. Now, the reason why it's good is because not all nodes are actually will be functioning properly, and those nodes will act as proposers of a block. The validator that stakes and proposes the block with the most transactions intact will be chosen as the proposer and given a reward for proposing a block or doing the right type of work. The voting for the correctness of the block is going to be done by the mining layer, and the miners out there, they're producing 1 hash per second or 60 hashes a minute. There's plenty of time based on the hash rate to basically settle the transaction and to vote for correctness within seconds. So 5 seconds, 10 seconds, and transactions become irreversible because those miners basically voted with their hash power for the correctness of the transactions. So the validators, the ones that stake, if they do their job correctly, they get the rewards. If they do their job incorrectly, they potentially will be slashed. The miners are the judging committee. So the miners out there, there's unlimited number of them. There's like could be millions of miners. Doesn't really have a number. They act as the kind of like this. They act as the people essentially, and the validators that produce the blocks, they act like representatives of the people, and they link the incoming transactions for the miners to basically to vote on. And the votes that are coming in from the miner group can always elect or remove uh, the node that's doing the block production. And it's a beautiful system because you end up having a fully decentralized layer that is a security layer formed by the miners, and then you have incentives for the full node runners that actually produce the blocks, but they get voted in by the network itself. So nobody's there essentially controlling anything. It's basically up to the miners to vote for or against a block of transactions. And obviously the stakers, they want to get the rewards, so they want those transactions to be included and to be proper and correct. However, there could be situation where a node is having a packet loss or it's overheating and it's actually missing transactions. So in case of Solana, if this happens, they end up having a fork, and then they have to work really hard to resolve the forks within the network. In the network that actually produces blocks in parallel by every node, there's no forking because the acceptance of the block is done by the mining layer of the network components or the miners themselves. So there's no forking because you don't have to resolve incorrectness of the chain. You can simply vote for something that is correct and come up with a consensus immediately of which blocks to include before any sort of forks can even occur. So that is why we can actually be, I would say, much faster than Solana, because Solana's most of the network traffic, and I have seen their network traffic. I run Solana node, so I can see what exactly is happening there. 92% of all the traffic is actually control traffic. It's the messages between the nodes that are resolving forks and exchanging blocks, essentially, and what they call voting transactions. If you go to SoulScan, you can actually see a distribution of votes versus real transactions. They have 150 transactions a second that are real, and then they have 3,850, which is 92% of the transactions that are votes, and the transactions that resolve forking. So if we can just do away with the forking by having parallel block production, we can be faster than them, and we wouldn't actually need to have a lot of hardware, beefy hardware that they require. We would have something that's affordable and relatively easy to acquire.
What is the
Jesus.
reason behind the forking mechanism? I'm guessing it's part of their security protocol.
No,
No?
So forking really comes from the design of the Bitcoin blockchain. So in the Bitcoin blockchain, you have your full nodes that, and you have miners, obviously. Every node in the Bitcoin blockchain runs its own version of the chain. Now, there are cases where in Bitcoin network, there's two miners that produce the blocks almost simultaneously within like 200 milliseconds. It happens. What happens then is one miner chooses, let's say, 2,000 transactions within the block, but the other miner chooses 3,000 transactions within the block. So now they have simultaneous block production, but the number of transactions is now different. So you have two different versions of chains on your blockchain, and it has to be resolved. Now, generally, Bitcoin has the longest chain rule. So whoever produces or builds the longest chain is elected by the chain itself, by the decentralization mechanism. When that happens and there's a fragmentation within the blockchain, there needs to be a block reorg. And you can look up what block reorg really means. Basically, it means that whoever has the wrong chain has to drop the blocks that are added to the wrong version of the chain, and then receive the other blocks and synchronize the chain. Now that's is really an efficient way of running a blockchain, and Solana actually implemented something very similar, except rather than having 10-minute block time, they're having 400 millisecond block time. That's how quickly their slots are produced, and slots in their case, as I mentioned before, is the definition of a block in Solana. The problem with running 400 milliseconds, which is half a second, blocks so quickly is that forking is inevitable, and it happens like every 5 seconds. Every 5 seconds, there needs to be a resolution of who is supposed to get the proper chain of the slots or blocks. Now, the only reason why forks exist is because of the sequential nature of handling the blocks. So one validator waits for the leading validator, the one that creates the 4 blocks first, and then they start. Now, if that validator halfway in drops off the internet but ends up transmitting the 50% of the blocks they produced, what happens is now you have half of the content that you otherwise would have had. But then in the same situation, they can have another validator that actually have captured the lost blocks and now is building a chain of a different branch. And that's a fork. So when you have different size chains built within a very short amount of time, those forks have to be resolved. Now, in case of the parallel execution in the design that I am proposing, we will have the miners decide for the block correctness and choose the right block pretty much every time from 21 plus validators out there. When I say 21 plus, it could be 100 plus, could be 1,000 plus. We don't know. But the point is, we want those validators to be producing blocks at the same time so that the miners can see that there's consensus between the proper production of the block and then vote for it. And of course, if some miner votes for the wrong block, but they're in the minority, they're simply ignored. So rather than repairing the blockchain all the time, we can ignore the minority vote and we can choose the majority vote based on algorithms rather than the data structure. So the data structure does not always win. And in the traditional blockchain design, like Bitcoin and Ethereum, data structure comes first and the algorithm comes second. In other words, you build the data structure first and then you resolve it. What I'm proposing is building the data structure by the algorithm before the resolution actually even needs to happen. So that is the major difference.
When you talk about the minority, I was thinking about this the time you spoke of this. Is this kind of, to put it more simply, where if somebody is deviating, that there is not proper data, that they're all the ones of the 21 or 100 or how many there are that are wrong would be different, and those who are correct would have consensus, so you know who's correct and who's incorrect. In other words, if you're not supplying the good data, it would be logical to think that you're going to be different than all the others, and nobody would nobody would come up with the same data as you if you're deviating. Let's say, I don't know, for whatever your CPU is heating or whatever the reason, your data is not going to match with the others. Is that kind of the way that you know who's correct and who's incorrect?
Well, it's basically like this. So every blockchain solution out there, they have some sort of a definition of what the block is. Now, the block is either produced within the amount of time or it's produced by the block size itself. So in Ethereum, there's the 12-second block times, and also there's this compute measure we call gas. Solana has compute units also, and they also have the time. So when you combine the compute units that you can include plus the time it takes to produce a block, you now have some sort of a target for the correctness of the data. And obviously, because the data is organic, it's coming from the end users, some nodes may have more data and some nodes will have less data. And there will be fragmentation between transactions. Some transactions will end up being included in block one in their entirety. And then some other validator will produce, or a block composer will produce a block that's only has 95% of the data. Now, if we run the hardware and the network pretty well, and there's no issues with the nodes, we should really match on the transaction count. Like, for example, we can say that every block is 100 transactions or so many bytes or whatever. And then there's a time that it takes to include all those blocks. Now, I'm not saying that there should be a particular time frame at all. With Solana, it's 400 milliseconds. But with Phantom does not track time whatsoever. They have 10,000 gas or 10 million gas per block, and as soon as it fills up, the block is produced. It's a very solid system that doesn't require time of any kind. And so what I was thinking is that rather than specifically have any sort of like a time cycle for block production, we just have the blocks fill up to a particular established constant. And as soon as you fill up that block in its entirety, you have the block producers package that block into a data structure. And so that data structure should be discrete, meaning that it should be the same across all the nodes, just because everybody follows the same rules. Now, sometimes your memory gets faulty and you have some bits flip, and you have zeros instead of ones and ones instead of zeros. And what happens is, as soon as you have difference in data, you produce different hash on that block, which actually means that your block is different than everybody else's. Now, if the majority runs good hardware and actually packages all of those, like let's say 100 transactions into a block successfully, then everyone's hashes should be the same. And that's how we assume that should the majority produce the same hash, the data is accurate for that common hash. And then the miners just look at the hash and say, okay, out of let's say 100 block proposers, we see 90% of them produce the same hash. That is the common hash that we're going to use, and we're going to look at the block, see if it's correct, give it a vote, and when it gets a threshold vote, like let's say 3, 4, 5 seconds, that actually means that the network has looked at the content, understood that the content that hasn't been tampered with, and then immutably added to the blockchain without producing any sort of forking. So it's kind of like a fork resolution is done even before the fork can be created, because nothing is really done in a sequential way. Like you don't have nodes waiting for other nodes that may be faulty to produce data so that you can build data on top of them. You just run data production in hash production in parallel, and you have the whole network vote on the common hashes that are produced. So I think it's a very relatively basic design, but a lot of everybody except Phantom is following sequential blockchain design, where the data structure is sequential. In Phantom, and I do get a lot of inspiration from them, they actually have the block production in parallel because they're using DAG data structure, where you can have parallel blocks produced and the network can consolidate without any sort of forking.
I'm like, this is why you mine Xenblocks, folks. This is insane. My back hurts from all this information, Jack. I'm pretty sure you're fucking AI itself at this point. Guys, let's go to some questions here. Tic Tac
I
has
just-
had his hand up.
I had people text me saying that Jack is a quantum AI.
It's insane, dude.
Jack,
All the data in
is
the
it-
scenario
is
is crazy. But
Is it
Tic Tac,
possible that
okay.
Well,
you
I'm
hear
pretty
me,
good
Jack?
at blockchains, but I suck at everything else except pull-ups. I do pull-ups really well.
Jack, about Xenblocks, let's say if Xenblocks are, I mean, this is never done before. So, like, if Xenblocks is the security layer and mineable, like the has a mineable coin and secure the network through mining. Now, if Xenblocks is the base security layer, so X1 comes on top, but it's kind of like anybody that kind of has idea to create a blockchain comes to Xenblocks and use the security layer. I know this is very difficult because the blocks need to be created and the miners need to know which block for which chain is, but this can be something revolutionary because then you will create just a security layer, and others can come. Can be even a company can come and create their blockchain and use decentralized security through Xenblocks. So what do you think about that?
I think the future is bright. I am super excited about it. I really feel like this could be Bitcoin reloaded. That's I mean, even if it's not gonna be Bitcoin, obviously nothing can be Bitcoin. Don't get me wrong. However, the experience we're all collectively having of really understanding how to build a blockchain and how to mine it and give it security and do it fairly without actually not uh, scamming in any way, like not producing a bunch of tokens, give a bunch of hopium and then watch it pump, have investors dump on the community. That is what's not happening here, and that is how Bitcoin has started. Bitcoin had this I would say immaculate conception or inception from the beginning, because nobody knew what cryptocurrency really was. Like, the crypto world did not exist. So Bitcoin had the benefit to be built by trial and error from the very, very beginning, without the effects of the venture capitalists requesting their chains to be this way or that way, or partner with this or partner with that, so that they can actually sell their tokens for profit. That is not what's happening here. If you want to get Xenium, you just mine it, and if you're mining it, you're providing security. So that's super exciting. It's a pure crypto in its purest form, and that's why I am like spending my days and nights thinking about it. And I think we can actually produce something that's like the world hasn't seen yet.
We have an interesting question from the man himself, Clout Cox. He said, ask about quantum computing and 256-bit encryption solutions to a quantum computer. Are you thinking of implementing defenses against this?
There's no if in some sort of parallel world there is a quantum computer, we'll just switch to the quantum algorithm, and quantum algorithms protect themselves against the quantum attacks. So the solution is as simple as that.
Yeah, fuck you,
No,
Ultron.
no one has monopoly on knowledge, and this is what we're fighting against. We're for the fairness of the knowledge and fairness of open source. Nothing should be closed source. Open source is free speech, and if somebody wants to fork Xenblocks, they can do it today. So you can run sync node, you can download all the blocks, you can swap the algorithm for whatever is that you want, and then you can say, hey, I'm building this parallel chain that's based on Xenblocks, just with a twist. And that's what open source gives us, because all of my code that I have produced and my team has produced has been sent to GitHub for reviews. So anybody can fork the data structure, can fork the whole blockchain that we have so far produced, and then build on top of it. So that's also super great.
Then they can call it titty blocks.
I see Mr. Zen Arena is in the chat. Zen Arena, what's going on, man?
We had another question.
Hi everyone.
This
Oh,
is tic tac toe Zen Arena. The reason why I am pointing to Zen Arena is because I've been looking at the TCP dump at the packets as they're exchanged on the peer-to-peer network, and one of the nodes resolves to zenarena.com or something like that, and then I realized that TikTok is Zen Arena node operator.
Yes. Hi. I had a question regarding the difficulty, and if you have a plan to keep up. For example, now it's like 90,000. Let's say a huge player comes along with, I don't know, a huge amount of hash power. How do you plan to keep up with this to keep the 60 blocks per second?
So that's a very good question, and I wish somebody asked it, and I'm glad you did. The the thing about hash power is that it's not just the hash power that you need. You actually need memory, and even if you have unlimited compute, as long as you have limited memory, you cannot produce blocks fast enough. And let me give you an example. And this is actually a segue into Argon 2 conversation. Let's imagine that it costs you $0 to actually to hash anything. And all you need is memory access. Just memory access. Like you can solve hashes instantly with, let's say, no time at all, zero time. It's a hypothetical situation, but let's explore that. Now, currently at 90,000 difficulty, this 90,000 is actually very close to 100 megabytes of data. 100 megabytes. The speed of memory on the GPU is about 20 gigabits per second. 20 gigabits. That is the speed of the video memory or VRAM on any device out there. Nobody is really faster than 20 gigabits, and you can look up the fastest GPUs today, and you can see that this is how fast you can actually access memory. Now, to produce one block or to solve one hash, you have to access that memory. You're limited by the video memory speed, and assuming that you can produce blocks instantly, the amount of time it takes you to access that memory is actually significant because you're limited by bandwidth. So it is the bandwidth to memory that ultimately drives the difficulty, not how fast you find the blocks. So if 90,000 becomes 200,000, that's, for the sake of argument, is 200 megabytes. And for you to access 200 megabytes, uh, to actually produce a block will take twice as much, twice as long. The relationship isn't really linear, but let's, for the sake of argument, assume it's twice as long. So your hash rate is actually controlled by the bandwidth, not your ability to solve the hashes. So that is why Argon 2 is what they call memory hard, is that you need to have memory access that is not unlimited. So it's kind of like the same situation with network bandwidth. Like currently, you cannot have more than 1 gigabit to the house. Eventually, you'll have 10 gigabits, and eventually you'll have 100 gigabits. But then, if we move the difficulty higher and higher and higher, where there's more bandwidth required to actually produce the block, then if everything is fair. And fortunately for video memory, the silicon and the channels that are being produced on the hardware layer, it isn't really following the Moore's law precisely. Moore's law is the speed of execution. So, like, in other words, how quickly you can crunch the numbers. But it is not the same how quickly you can access the numbers. And so the access is what drives the difficulty, not necessarily the silicon speed itself, like not the transistor speed or not how many transistors you got, but rather the channels to access the data structures to manipulate it.
That is wonderful. Thank you.
Man, I think we have one more question I'll ask you. It's from the comment section, and there's another one about basically, what was he saying? He's saying, is Xenblocks the current implementation going to be used for X1, or is this like a test net and a new POW will be launched when X1 is launched?
So
There you go.
I call it a mainnet alpha. So mainnet alpha is basically means that there will be no removal of the hashes that you own, because right now, that the way that we coded the system, you're using your Ethereum public addresses, like the addresses that you actually own, and that address is embedded within the hash itself. So whenever you produce a hash, or anybody who produces a hash, you can actually see the owner of who produced that hash. Okay, and so that hash is like an NFT. It's non-fungible. It belongs to you, and you have as many as you have produced. That data is now freely flowing across the nodes. Anyone can bring a node, download the open source code, run sync node, get all the data for everyone. Everyone has the same data. No one can change the Ethereum address and expect the hash to be the same. Even if you change one digit, your hash will no longer be valid and the algorithm will reject it. So basically, anybody who is mining Xenblocks today, they're mining valid, algorithm reinforced hashes that belong to the Ethereum addresses that you have private keys to, which is the ultimate ownership. As long as you don't give up your private keys to your Ethereum address, your hash is stamped with your proof of work, and nobody can take it away from you. So even if the
That's
whole thing
awesome.
just disappears somehow, we have thousands of nodes that actually downloaded all the data, and that data actually is immutable for as long as your private keys stay private. So that's why I call it mainnet alpha, is because we're actually producing real work, and there's no need to remove it because it really belongs to you.
Nice. And then 5 years from now, we can flex our OG-ness when the stuff hits the market.
Yeah, I mean, like you can basically say that this is the difficulty I mined with. The difficulty is part of the hash. This is my address that I hashed it with. It belongs to me because I own the private keys. So it's really like an NFT. A block is like an NFT, and then the Xenium reward is basically adjusted by the schedule of the code or of the network. So in a year from now, currently you're getting 10 Xenium per block, but next year it's going to be 5 Xenium, and then it's going to be 2.5, and so on and so forth. However, someone can say, I don't like the word Xenium, I want to fork the chain, and I'm not going to be awarding 10 Xenium, I'm going to be awarding 100 Unobtainium, or whatever the name that they come up with. They can give rewards for the blocks that you own, and I'm actually like really curious if somebody would do that. Then what will happen is that the blocks will remain immutable and in your pocket, so to speak, for as long as your private keys are yours and your seed phrase is yours. However, somebody can say, okay, I'm forking this and I'm giving this different name Unobtainium, and I'm going to reward 100 Unobtainium for every block. Okay, and this is totally valid use case to do it that way. So um, yeah, so the reward is separate from the block, but the block belongs to you, and whoever comes up with a game to use your blocks, you can actually give a different type of reward if you wanted to.
Man, there's levels to this, huh? It's pretty cool.
Yeah, but the TLDR is that the blocks are non-fungible; they cannot be split or given the ownership away for as long as you did not give the private keys away. But even if, like, Ted Ape decides to give his private keys to me, that's not gonna work, because, like, what if he decides to give the same private key to everyone else? Like, it's just not gonna have the same value. So the private key in this case, like, only has value for as long as the person keeps the private key, which actually is part of this economic security model.
That's awesome. It sounds pretty fail-proof then. I always wondered that too. I was like, what if you just give your private keys to everybody?
Yeah,
That's
well,
cool.
then it's then whoever controls, whoever accesses your key first can do things with it, and no one else in the group can do anything about it.
Well, cool guys. I appreciate everyone coming in tonight. I didn't expect it to get this big. And of course, Jack, thanks for coming in and tolerating all the questions and stuff. Thanks for all the questions, everybody, and people contributing to the discussion. I'm gonna have to put my kid to sleep here in like 5 minutes, so I'm gonna close out the space. I won't delete this one. I have a habit of deleting my spaces, but I won't delete this one because there's a lot of good knowledge in it. So you can find it on my profile. But yeah, if anyone else has anything else to say, speak now.
Well, that was fire. That was fire. I'll just say that. That was awesome. Thanks for that, Jack.
Yeah, absolutely.
Yeah.
You guys are very welcome, and I'm just glad to have you guys in the community. And let's keep pushing the state of the art. Let's amplify first principles. Let's say no to centralization and to pump and dump and hopium. Let's just get things off the ground and just enjoy the journey. So I'm definitely enjoying it myself.
Let's fucking hash.
Let's go. Let's learn. Let's
LFH,
grow.
LFH, LFG, LFH.
Take care, guys. Night.
Thank you.
Thank you.